Today we are looking at slopes of parallel and perpendicular lines. So your essential question is, how do I write equations and graph parallel and perpendicular lines? Your learning intention. I'm learning to recognize parallel and perpendicular lines, find their slopes, and write their equations. So write the equations of the lines below with the given constraints. Draw both lines on the graphs below. So we want to go through -4, 3, and parallel to x equals -1. Oh my. What do we know about the line x equals -1? It is vertical. So let's graph that first. Okay, so I'm looking at -1. Here's -1. And it goes through -4, 3. What do you notice? What do you see? Well, x has to be -3, or x has to be -4, because it's going to be that perfectly vertical line. So if we're looking for something parallel and it's vertical or horizontal, there isn't much, you just really have to think about what it means. So it is going through 2, 1, and it is perpendicular to x equals 3. So x equals 3 is here. It's a perfectly vertical line. So the line that would be perpendicular would be horizontal. Let's find the point 2, 1. And this becomes y equals 1. Okay, see if you can do that last one on your own if you haven't tried yet. Okay, it's through this point, but it's 4, -4, it's perpendicular to y equals -3. So if y equals -3, it's going to be that horizontal line. And we know that the perpendicular will be vertical. So let's find 4, -4. This will be our vertical line. And that becomes x equals 4. So if you're looking at horizontal and vertical lines, it's really easy to find the parallel or perpendicular. If it's parallel, it will just be through the x value or the y value. If it's perpendicular, then it becomes, instead of y, it becomes x, and instead of x, it becomes y. Y equals. Okay, how do we write those equations? Well, the endpoints of one side of a square, P, Q, R, S, are at P is 1, 1 and Q is 3, 4. What is the equation that contains the line PQ, the line segment PQ? Okay, so if we're looking at this, step 1, find your slope. So it's a change in y over the change in x. This would be 4 minus 1 over 3 minus 1, which becomes 3 over 2. Now, we have to find the rest of it. That's our slope. We will use the 0.11 to find the b value. 3 halves x plus b, y equals, or 1 equals. Oh, let's use okay. 4 equals 3 halves times 3 plus b. 4 equals 9 halves plus b. Okay, 4 would be 8 halves. 8 halves minus 9 halves gives me negative 1 half. Negative 1 half equals b. So, if I'm looking for that equation, it becomes y equals 3 halves x minus 1 half. Okay, what about the slope of the line that contains SP? Now, we know that if that's the corner, that the corners intersect at a 90-degree angle. So we're looking for the opposite reciprocal of 3 halves. So this will become negative 2 over 3. We have to use the point P. So y equals negative 2 over 3x plus b. 1 equals negative 3 over 2 times 1 plus b. Okay, 3 halves plus negative 3 halves plus b. Add 3 halves to both sides. This is 2 halves plus 3 halves gives me 5 halves. So 5 halves equal b. Y is equal to negative 2/3 x plus 5 halves. I messed up right here. I should have had negative 2/3. And instead, then this would be 3/3 plus 2/3 gives me 5/3. Okay. So if we're looking at PQ, that would be the first side, and then QR. So that you go PQ, then QR. Are they parallel or perpendicular? Well, they would have to be perpendicular, but why? Because they are consecutive sides of a square. And squares have 90-degree angles. So, if you're looking at them, we know that they have to be perpendicular because they're sides of a square. If they're sides of a square, then they have that intersection of 90 degrees, which is perpendicular. Okay, a trail through a national park is being extended to include side paths to different natural features. The planners would like to add a perpendicular path that leads to a buy-in tree, a unique type of tree that grows new roots from the canopy down to the ground. The trail and the tree are modeled on the coordinate plane. What are the slopes of the current and the new perpendicular path? Well, let's find the slope of the first path. We've got the 2 points. So we would have 7 minus 5. It's delta y over delta x. 7 minus 5 over negative 6 minus 0. 7 minus 5 is 2. Negative 6 minus 0 is negative 6. So the first slope would be negative 1 over 3. To be perpendicular, your m will equal. The opposite of negative is positive. The reciprocal of 1/3 is 3. So let's write that equation. So your slope is 3. We're going through the point negative 2, negative 5. So I start with negative 5 equals. Three times negative 2 plus b. Negative 5 equals negative 6 plus b. I'm going to add 6 to both sides. 1 is equal to b. So y is equal to 3x plus 1. Okay, so it says that a trail marker will be placed where the trail and path intersect. What will be the location of the marker? I think that it would be easiest just to draw the line and look. So I start at 1. I go up 1, 2, 3, and I go over 1. So by counting, I notice the point 0, 5 is where they intersect. No, it would be at the point 1, 5. 0, 5 is on the line here. So I go from here, I go up 1, 2, 3, and I go over 1. And it wouldn't, that's not quite correct because this is by 2's and I did not go over by 2. So what we want to see is where they are the same. So as you could see, it's not going to be the b value, is going to be a fraction. So as I go, I'm going to start with the equation. I'm going to start at 1, and then I'm going to go up 1, 2, 3, right 1, then I'm going to go up 1, so that would be the point 1, 5. Actually, it would be 1 and then 4.5 because it's not going to quite be to 5. 5 is where it crosses here. And remember, that's an approximation because we'd have to set up a system of equations to solve, and we have not learned how to do that yet. So the planners want to add another side path leading to a small waterfall. This path will be parallel to the path of the buy-in tree. Is the path to the waterfall perpendicular to the trail as well? Explain. Well, yes, it would be. And it's because if it's parallel to the buy-in tree, then it has the same slope. And if it has the same slope, then it will be the opposite reciprocal to the first path. Because the slope is the same as the path to the buy-in tree. That slope is the opposite reciprocal to the first. Okay, so how do you know when you're successful? You know you're successful when you can recognize parallel and perpendicular lines, find their slopes, and write their equations. Parallel lines, perpendicular lines, same slope, opposite reciprocal. And remember, to find your b value, you substitute one of the points in and solve for b.